On the evening of July 17, 1996, at JFK International Airport, TWA Flight 800 taxied away from the gate and took off into the humid summer twilight. 12 minutes later, as the Boeing 747 climbed through 13,000 feet on its way to Paris, the plane's transponder pinged air traffic control for the final time. The aircraft vanished from radar. Down on the ground and out on the water, eyewitnesses watched a terrifying sequence unfold. They reported seeing a bright streak of light shoot upward into the dark sky, followed immediately by a massive, raining fireball. The FBI launched a criminal investigation, suspecting a terrorist bomb had been placed on board. However, based on the vivid eyewitness accounts, the public consensus gravitated toward a different theory. A rogue U.S. Navy surface-to-air missile had struck the plane. The eyewitness accounts perfectly matched the profile of a missile strike, creating a gap between public perception and the physical reality of the wreckage that investigators were beginning to recover. To find out what actually brought the plane down, the NTSB launched a massive recovery effort. Over months of grueling work, they dredged more than 95% of the aircraft from the dark floor of the Atlantic Ocean, reassembling the skeleton of the 747 inside a hangar in New York. Inspection of the wreckage provided no evidence of an external weapon. There were no high-explosive shrapnel patterns, no chemical residue on the victims, and a total absence of the microscopic metal pitting caused by a missile detonation. This diagram of the fuselage shows what they found instead. Looking at the metal skin surrounding the center wing fuel tank, investigators noticed the damage didn't push inward from an external strike. The explosive pressure had pushed the outer metal skin outward from the center. The explosive force had originated from within the fuselage, yet the center wing tank on that flight was almost entirely empty. Investigators now had to determine how a near vacuum of fuel could transform into a devastating bomb. Because TWA 800 was only flying to Paris, the center wing tank held just 170 liters of residual jet fuel, a thin puddle spread across a massive structural cavity. In its liquid state, jet fuel is difficult to ignite. A lit match would be extinguished as easily as if it were dropped into water. This cross-section shows the effect of a routine 1-hour tarmac delay. Directly beneath the center tank, the plane's air conditioning packs ran continuously to cool the cabin. This excess heat radiated upward, baking the residual fuel until it evaporated into a highly explosive vapor. Sitting inside was the fuel quantity indicating system, powered by low-voltage wires running directly through that explosive environment. The voltage inside these wires was too low to create a spark, but this 747 had been in service for 25 years. Hidden inside the airframe, wire insulation had degraded and frayed. Within those densely packed bundles, a high-voltage short circuit from a neighboring system jumped directly into the sensor lines. The industry's reliance on keeping sparks out of an environment that was engineered to create explosive vapors had reached its limit. At 13,000 feet, that rogue electrical surge finally reached the center tank and released a tiny, fatal spark. In a fraction of a second, the vapor ignited, triggering an explosive overpressure event known as a deflagration. The rapidly expanding pressure shattered the keel beam, which serves as the structural spine of the aircraft. This 3D model illustrates the structural consequence. Without the keel beam to support the airframe, the nose and cockpit sections snapped off the fuselage and plummeted toward the ocean. With the heavy nose section gone, the center of gravity shifted. The engines were still producing maximum thrust, causing the headless airframe to pitch upward and climb thousands of feet into the night while trailing burning jet fuel. That upward streak of light was the missile thousands of eyewitnesses swore they saw. In reality, it was the burning aft section of the aircraft, decapitated and tail-heavy, performing a final climb into the upper atmosphere. The investigation forced the aviation industry to face a difficult reality. Within miles of electrical wiring, guaranteeing the exclusion of every electrical spark was a physical impossibility. This animation shows the regulatory solution that followed: nitrogen inerting systems. Rather than relying on the absence of sparks, these systems actively pump oxygen out of empty fuel tanks and replace it with inert nitrogen gas. By starving the tanks of oxygen, the vapor cannot ignite, regardless of electrical failure. Safety no longer relied on the impossible task of preventing every spark, but on ensuring the environment inside the tank was incapable of exploding. TWA 800 was a profound tragedy, but the forensic process used to analyze the wreckage led to the removal of these hidden electrical vulnerabilities from the modern fleet.